All right, welcome to the official start of Math 50. So now that we've completed the essential skills, we're going to get into the content of the course. So we're starting with chapter 1, which is linear equations, inequalities, and applications, as well as some other stuff as well. But we're going to start with section 1.1, which is linear equations in one variable. And before we get there, we're going to start with a little bit of language. The first word that you have to be comfortable with is the word term. Now, a term is really anything multiplying together. This consists of numbers, variables, product or quotient of numbers and variables, and then they can be raised to powers. So down here, I just have a list of different examples of terms. You know, people are used to something like 4x being a term or negative 5x squared being a term. They can also have things like square roots. They can also be multiplying by a half, which is the same as dividing by 2. So getting used to that these two terms are the exact same, just written in a different format. And the one that usually kind of gets people is this one. This is an example of a term because everything's multiplying together. So people usually think of terms being separated by plus and minus signs. Like if you look down here, right, we have 1, 2, 3, 4 terms, and they're separated by plus and minus signs. But if we made any of them multiply together, then we can make it a single term. So even here where we have plus and minus signs, this is actually 1, 2 terms. This is something you'll get used to throughout. We'll talk about it in different chapters, but just to mention that now. Now, we needed that word because the first topic we're going to talk about is the difference between an expression and an equation. And we're going to do this specifically about linear expressions and equations. So all of chapter 1, in fact, chapters 1, 2, and 3 are all on the topic of linear. Now, to be linear, it means that the highest exponent on any variable or term is going to be a 1. Now, that's what makes it linear. What makes it an expression is that it's a collection of terms. So an expression is a collection of terms. A linear expression is a collection of terms where the highest exponent on any term is 1. Now, an expression can be identified because it does not have an equality sign. And that means that you can't solve it. The only thing you can do with an expression is simplify. What does simplify mean? Well, it's things like clearing any parentheses. It's combining like terms. It's performing the operations that you can perform without actually solving for a value of x. So I have two examples of expressions down here. This one, I have a collection of 4 terms where the highest exponent on x is 1. So this is a collection of linear terms or a linear expression. And when I look at this, there aren't any parentheses. The only thing I could do is combine like terms. So I have a negative 3x and I have a negative 5x. You can combine those together because they have the same variable raised to the same exponent. And in fact, you could rewrite this expression as negative 3x minus 5x plus 2 minus 6. So there's this thing called the commutative property of addition, which states that 2 plus 3 is the same as 3 plus 2. You're allowed to change the order in which terms are written, as long as you take the sign with it. So when I'm collecting these like terms, I've got negative 3x's, and I'm taking away 5 more x's, which means I have negative 8x. And then I'm collecting the constants, so I have a 2 and I'm taking away 6, and I'm down to negative 4. So this is a simplified form of this expression. There is no value of x that makes this true. It's not an equation. All I've done is written it in a simpler form. Okay, same thing with this one. What can I do? Well, I can't combine like terms yet because there's this parentheses that I need to do first so that BEDMAS kind of holds true. So I can't do anything in the bracket. There are no exponents. There is no division. I'm going to do my multiplication. So I'm going to multiply the 2 through. I get 2 times x is 2x. I get 2 times 3 is 6. And then I'm going to distribute this negative 5. Negative 5 times 1x is negative 5x. And negative 5 times negative 2 is positive 10. And then again, I can collect like terms. Now you don't need to rewrite the expression in a different order. You can literally just go 2x, take away 5x is negative 3x, and then 6 plus 10 is 16. And again, this is an equivalent expression to this. It's just in simpler terms. I performed the operations that I could. And now what we're going to do is move on to a linear equation. Now, to be linear, again, the highest exponent is 1. But to be an equation, you're going to equate two linear expressions together. So it does have an equal sign and can be solved. So an example of a linear equation would be something like ax plus b is equal to c, where the x has a highest exponent of 1. That's what makes it linear. And the fact that there's an equal sign is what makes it an equation. And we're going to be able to solve these. We're going to find the value of x that makes it true. Now, it's really, at this stage, not super duper important, but it will be important by the end of this course to be able to identify what every type of equation is. So I have 5 equations written down here, right? 1, 2, 3, 4, and 5. And what I want to do is determine which of these are linear. So which of these has the highest power on the variable of a 1 and has an equal sign, right? So is an equation I could solve. So I'm going to leave you 2 seconds to think about this. And I'm going to tell you that there's 2 of these that are linear equations and 3 of them that aren't. Can you identify the linear equation in X, or linear equations in X? Pause the video and give it a think. Okay, so hopefully you discovered that this one and this one are the only linear equations. They're the only equations that are of x where the highest exponent of x is a 1. So this is x to the 1 plus x plus 5 is equal to 2. And this one I could also write as 1/2 x minus 2/3 is equal to 5/6. So both of these have an x in the numerator and their highest exponent on x is a 1. Okay, let's look at the other 3 and determine why they aren't linear. So this next one, the reason this one's not linear is that there's an exponent of 2. This one is actually quadratic. We are going to be talking about quadratic equations in chapter 5 and 8. Number 4, the x is in the denominator, which makes this not linear. So even though the exponent on x is a 1, I could actually write this as 2 times x to the negative 1. Again, we're going to be covering that in chapter 4. But just know for now, if there's an x in a denominator, it's not linear. This is actually a rational equation. And we're going to be talking about these in chapter 6. And then last one, this one's not radical because is not linear because there's a square root sign over the x. This is actually a radical equation. And we're going to be covering these in chapter 7. So like I said, at this point, if you're a little bit confused about this, it's okay. I'm showing you the 2 that are circled are linear equations. I'm telling you what the other 3 are. Doesn't really mean anything to you now, but it's kind of nice to know where we're going with this. And it's nice to know that at the end of the course, you're going to be able to solve all of these. Yay. Okay, but let's go back to linear equations. When you're solving a linear equation, you're finding the value of x that makes the equation true. So if I want to know if 3 is the solution to this equation, what do I do to check? You always can check an equation by plugging in the solution for x. So what I always do is I take a line and I draw it from my equal sign. And I'm going to check, is left side equal to right side, right? That's what you're going to ask yourself. When I substitute in that value for x, will the left side of the equation equal to the right side of the equation? So on the left-hand side, I would have 3 divided by 2. So I've substituted in that 3 minus 2/3. Now, I chose this one on purpose. I chose kind of a harder question that's not so easy to just see whether it is the answer or not, because I want to show you that you're allowed to use your calculator in the course. If I wanted to check if this was true, I would plug this in. So I'm going to grab my calculator. Okay, and I'm going to plug this in. This is 3 divided by 2 minus 2 divided by 3. And I get 0.83 repeating. It's not a great answer, but that's what I get on the left-hand side. Now I want to see if the left-hand side is the same as the right-hand side. So for the right-hand side, I'm going to plug in 5 divided by 6. Since 5 divided by 6 also came into 0.83 repeating, that means that left side does equals right side, which means that the solution is 3. Now, to declare that something is a solution, we can put it in a solution set. There's these like weird little curly brackets. They exist on computers, right? And they're also mathematical terms. They declare a solution. So if I'm going to say that 3 is the solution, I can declare it by saying this is the solution set. Awesome. So now what you're going to do is you're going to go to your blue package, so your practice questions, and we just finished 1.1 linear expressions and equations, and you're going to practice just these 5 questions. So based on what I just taught you, you're going to practice just a few questions. When you feel confident with it, you can come back and then watch the next video and do the next set of questions. Now, I've only picked a sample of what you can do. If you want to do more, you can. But what I've really tried to do is go through and be like, okay, I really think this covers each of the different skills that students need to understand this topic. So I really do recommend trying all 5. If you need more, that's great. Awesome. Good luck.